Greetings, it's the welding crew, and today we're not doing ham radio today, are we, Chris?
No.
We're doing welding. So yeah, let me show you some of the new equipment that we've got. Chris, what are you doing today?
Just a bit of TIG welding.
Oh yeah, bit of TIG welding. So what we've got here then, we've got this Kempi torch. This is the latest, well, one of the latest Kempi machines. It does AC, DC, and a very nice piece of kit. So in other words, you can weld stainless steel, aluminium, carbon steel, all different material types and thicknesses. What I like about this machine, now that I fully understand it, he says, we can set it up automatically and get it to work with preset settings. So, like for example, you can choose what material: stainless, aluminium. So let's just pretend we're going to weld some aluminium. I'm going to totally mash up Chris's settings now. So we'll select some aluminium and we'll go for a serious substantial material thickness of 6mm. So that's the material thickness. Then we'll choose the joint type. So this one's a butt joint, a corner joint, that's an edge joint, that's a lap, that's what we call a fillet. And then we've got a pipe joint, which is similar to a butt, but that's a positional pipe joint. And then what we've got here is what we call pipe to plate. So we can choose, we'll go for the butt joint. So press the butt joint up. And now we'll talk about what position would we like to weld it in. So we have different terminology to put on drawings to tell us welding positions. So that means where is the torch coming down. So that's PA, that's flat position. That one's PA, PB, that's horizontal position. PC, well actually PB is horizontal vertical, PC is classed as horizontal. Again we've got another horizontal vertical with a PD. And PE is what we call overhead. PF is vertical up. And PG is coming downhand. So we've got all different positions, and then we do have a pipe position where you're going around in a positional 45-degree angle called high-low 45. That's really skilled. That's not on here. But anyway, let's go for a PA. So now we've got the recommended settings on that one. It's alternating current, which we use for aluminium, 235 amps of power. It recommends that we use 11 litres a minute of argon and 35 litres a minute of helium. So that's quite expensive. But if we do that, we'll get a decent weld profile like that. That's an image of the actual fusion. You can see the preparation, and that's how you weld some 6mm aluminium using TIG. Oh, you like that, Chris?
I do like that. I had no idea that machine even did that.
Oh yeah, we've got some good gear here. This next piece of kit I'm going to show you, this is the latest Kempi MIG set. So the TIG set's what we use for aluminium, stainless, exotic steels and aircraft. It was designed for the aircraft industry initially. Now we're going to look at what we have, some high-speed semi-skilled welding using what we call the MIG process, or MAG, which is metal active gas. Let's take a look. This is another Kempi set. This is a MIG torch, so semi-skilled. Press a button, gas comes out, wire comes out, and we get a short circuit and we start to weld. So again, we've got some nice simple features to look at. So we have a few basic controls. This is what we call wire feed, so that determines how fast and how much wire comes out in meters, so 3 meters a minute of wire if I press the torch. And then to melt the wire, we have the voltage control. So this machine has quite a good coverage, quite a powerful piece of kit. It goes up to 32.5 volts. I wouldn't imagine what thickness. It's going to be very thick material. I never weld at 32.5. Generally weld a maximum of 23 volts, and that's for something like 10mm thick material. But typically we'll be down at 20 volts, 6mm, and maybe if we're welding some vehicles 1mm thick, we might be right down to 15 volts. And then the wire speed, they'd have to be dropped back to 2. So we'd have a little bit of wire coming out and the minimum heat to melt it. So that's how it works. But inside we've got what we call a wire feed unit. So this is pretty nice. It's got 1mm diameter carbon steel wire. We can run stainless steel on it, aluminium and normal carbon steel. We can change the wire diameters, 0.6, 0.8, 1mm, 1.2 for flux cord. And to do that, we just undo that, swap it over. We've got some drive rolls just here. These drive rolls come out and they have different grooves for different diameter of wire. It's essential you get all that right for a smooth feeding weld and a smooth feeding torch. So there you have it, Chris. That's a little bit of Kempi MIG. What do you think?
Yeah, good. Really good machine.
Shall we go have a look at our new machine? So what we're going to do, we're going to look at this next piece of kit. This is an industrial powered MIG set, and it's got high amps, so it's for welding very thick materials. We've picked up 2 of these. One's air cooled and one's water cooled. Let's have a quick look at the air cooled one first. So this bad boy is a nice Kempi MIG set. It's got a separate wire feed unit on top. that can be suspended overhead if you need it to be. Extend your cables, your harness. I've just powered it up. So it's an air-cooled MIG plant. Very nice piece of kit indeed, with the typical air-cooled torch. So we're going to fire that up. You can see the parameters have just been adjusted. I press the button. It's set at 16 watt. That's your wire speed, and 17 volts. So that'll need a little bit of manipulation. So I'll do so. We just control this. This just alters the volts. That alters the wire speed. All very fancy. Let's turn the wire speed so as you can see the digital readout. So I'll probably set that to about 3 on this machine, and I'd up the volts to around about 22 volts on that. It's a very nice piece of kit, good feeder, and that's an air-cooled Kempi set. That's a Kempi. This is a Lincoln Electric. This old-school transformer unit. It's actually a 300 amp set. It's got a couple of ranges, no digital readout, but does exactly the same kind of thing. For you kind of guys who don't like the digital stuff, it's an analog transformer set. Still very good and still in use. Now that's what you call a bevel, Chris. Very nice. So is this for your new antenna?
This is.
So it's not all about work, is it?
No, sometimes it's not.
Oh, we've got Tommy, our technician, and what we've been doing, we've been giving you a workshop tour, haven't we, Chris?
Yep.
So right now we're saving the best to the end. This is the water-cooled big boy stuff. So this is what I've been looking forward to. I've never had a water-cooled welding set before. So obviously these are all college property, but we get to play with them all day long. So this is something fancy. So over here we've got the refrigeration water-cooled unit at the back, and then we've got the specialist torch. So this torch is a lot heavier. It's a brand new torch actually. There's the harness. Within the harness you've got some basic channels of water running through, keeping the head of the torch cold, and you can see the actual water harnesses there as it connects out of the machine. So similar thing to what you just looked at. You've got a separate wire feed unit, and then you've got a transformer below. So we'll have a quick look inside the wire feed unit and then give it a... So again, very similar to the one I showed you before, but it's a top unit, so it's got some 1mm diameter carbon steel wire. A lot of people think it's copper wire. It's not. It's just coated in a copper coating to conduct electricity and also prevent it from getting corroded. So I've got the parameters, as we say, the settings. We've got 3.8 on this one for the wire speed, and the voltage is set to 26.8. That's just how it came. I'm going to try it at that. Obviously I can adjust it to my preferences. We've got some plate, a little bit of carbon, 6mm plate. We'll just give it a quick shot with it. Okay, so I've got this new machine. This is the liquid cooled or water cooled torch as opposed to the air cooled torch. So I've got a big shroud on it. This is the shroud. This is what we call a contact tip. That's a gas diffuser. This is what we call a gooseneck. Insulated torch body, trigger switch and a harness. So there are all your components. These contact tips change and you get different sizes depending on what wire diameter you're using. You can get different torch sizes, but with this being liquid cooled or water cooled, it's a big one, so it's quite heavy. So the advantages are you can weld all day long and your torch won't get warm, but really the amperage, the power, the material thickness you can weld is substantial. So that's what the water cooling lets you do. So I've tacked up a piece of material. Tacking is just temporary joining it. Just a bit of scrap material. Let's see what the weld goes down like. Are you ready? So this is MIG welding, or mag welding in actual fact. Wow, I'm not just saying that, but that is one hell of a nice weld. So that machine just put that awesome weld bead down with the awesome guy doing the awesome weld. And that must have been me. So yeah, very nice indeed. Horizontal vertical T-fillet weld with the new MIG water-cooled torch. It's a cake. Yeah, that was pretty good with that, Chris. I'm impressed. I'll let you have a go. Your turn now. See if you can knock out a nice weld on this. And whilst he's doing that, I'm going to say thanks for watching this one, and we'll see you on the ham radio bands somewhere soon, and it'll definitely be me. Catch you later.
Fantastic welding machine, is that?
Yeah, nice, Chris.
Really nice.
Very nice bead. So, yeah, fantastic looking weld profile, Chris. I taught you well.